My name is Didier Gava and I'm storage architect for netapp, and today the topic will be the third platform. So what does it mean, third platform? I will show you in three slides. Today in the IT market, what we see, we have several problems to solve, and one of the problems is the retention of information, and depending on which domain you are, you need to keep the data either for life or maybe for life plus X years. For example, in UK, that's my colleague told me, you have some records need to be kept 10 to 20 years after your death. So the data need to be stored, and you have also your payroll need to be kept for life, and these need to be stored somewhere, and you will have some data management issues, how to store, where to store, and how much data you need to store. So this is all the challenges you have. So you have all the bar with different businesses, and you will see after some businesses here you need to be kept at least 5 years, and then it can be reduced to indefinite for some record like corporate records or health records. Another problem we have, and I saw in the room, everybody has smartphone, doing Facebooks, doing Instagram, Twitters, and basically this is a chart we do in for 1 minute. So from the origin of storing data up to 2003, guess what? We store 5 billion of gigabytes of data. 10 years after, almost 10 years after, in 2011, we stored the same amount within 2 days. 2013 it was 10 minutes, and today every minute we store 5 billion of gigabytes of data. Why? Because people is doing tweets, doing emails, doing Facebook, doing sending a lot of information, and these information need to be stored somewhere. So, as netapp, and we talk to all analysis, we have what we call the third platform. So, third platform is naming from IDC. Gartner used the B model naming, and what is behind the third platform? This is the history. So the first platform, what is it? Is a terminal, client servers. It was before I was born. So it's a mainframe. Basically, you get 1,000 applications built on the mainframe, and designed for millions of users. Then came the second platform, and the second platform, what is it? The second platform is the LAN, internet, client server type of operation, and this was done end of last century, from the 90s to year 2000, because computer is commoditized, and we can do tens of thousands of applications for hundreds of millions of users. Now the third platform is what we call SMAC, like not that one, but this is social, mobile, analytic, and cloud. The acronym of SMAC, SMAC. And what do SMAC is? The application is driving the hardware. Okay. What does it mean for IT personnel? Is a nightmare, because you need to reserve some space, some CPU cycles for this kind of application. And this is a million of applications for billions of users. So, for example, if you take Twitter, You send a tweet, and the tweet needs to be stored somewhere and redirected to all over the world, and this need to have the infrastructure in place to run it. So for IT, what does it mean? As I said, it's a nightmare, but the third platform is something easy to manage. So need to be easy to manage. You need to give some CPU cycle, as I said, some capacity, and managing need to be simpler. Also, we get the reliability, availability, serviceability against direct attack storage. Why? Because for this kind of application, people used to take a server with some disk inside and running the application. But it's good for small application, for small number of users. But if you scale up 2 million of users, you need to have no stop for servicing your data. Imagine that Twitter stops servicing for 2 minutes. It will be in the committee will be a tolle. The second platform is the client servers, and this is everybody knows it's a LAN, it's a SAN. You have your servers, you get your computer, and you run your application, and this is something cost effective. And for the third platform, what is important is getting the same requirement on the second platform. As I said, simple to install, simple to manage, and getting the reliability of the second platform. So the traditional center, as I said, is SAN. Something is shared between all the servers, and something important is the scalability. Scalability is the keyword because you need to add applications, you need to add compute power, and you need to add the storage as you wish. And also on the third platform, what is important is managing the configuration and managing how you manage the configuration is using, for example, Dockers. You have your containers, and you said this will be for that application, this one will be for the other application, and you duplicate your containers to what is needed for your customers. Okay, so at netapp, you know, netapp is very well known for the fast series, but netapp is not only fast, they have also different product line. And one of the product line which fit inside the portfolio on the third platform is the E-Series. E-Series is not a new product. E-Series came from the engineer acquisition by netapp 5 or 6 years ago. And the E-Series, what is it? Is a block storage. It will give you the bandwidth as required. So the portfolio, the E-Series portfolio consists of 3 products. Entry level is the 2000 product line, which has this specification. Mid-range is a 5000 product line, has the other characteristics. And also we have EF a flash product line, which is the EF560, which gives you 825,000 IOPS within 300 microseconds latency. And the bandwidth will be 12 gigabytes per second sustained read application. You have also 3 types of enclosures, and the controller are inside the enclosures. What you see is you can scale up by the capacity. You add more shelves, and you decision the shelves, or you get by the performances. You just add a bunch of E-Series, and you get the performances. The performances is cumulative. By the numbers, since the acquisition, we already shipped 1 million systems. So it's not 1 million controller, it's 1 million systems. So it's enclosure with two controllers. What does it mean? We we build 3,000 units per week, and if we get a problem, we will know it. And on the field, we didn't see a huge problem which caused data corruption, which caused sending field support engineer on all locations to fix the problem. I never said that we never have any problem. We have problems like everybody, but the problems are very, very rare. We have more than 20 years of experience. We have people in the company close to be retired. They get 40 years with the company. He knows the product since ages. We have more than 200 patents, 885,000 entries in our IMT. That means we certified almost everything on the earth. For example, all SBAs, all switches, all versions of the drivers, and in the Sun deployed technology. Currently, we are number one. So, what are the go-to-market with the analytics solutions? Basically, we have two types of workload. We get on your right the specialized enterprise, which are the intensive computing. We use Lustre, GPFS, StoreNext, you name it. We also have product and architecture for the media and entertainment. We have also object storage. We have also security and intrusion detection for as an application. We also have video surveillance architecture, and we work mostly with we are open. We just provide the hardware, and we work with the partner who knows better than me the VMS software, and we need to build the solution around. On the third platform, we have three layers. We have analytics, we have object store, we have open source, and basically I will focus on NoSQL databases, Hadoop and Splunk, because I have no time to develop all the object store and open source. Basically, if on the object store, for example, we have bricks with set and Swift, the communication layer between the E-series and set, and the web scale architecture is our storage object architecture. On the open source, we use OpenStack, we use Nagios as the framework, and we use Puppet also to communicate in the OpenStack world. So, how many of you saw the movie 1984? Big Brother is watching you, George Orwell. Basically, he's coming today. So, machines generate data, and each time you go somewhere, we know that you are somewhere. Your cell phone has a GPS, so somebody can spot you. And this is scaring me. Why? Because machine generate data, and somebody behind will analyze the data, and if, for example, somebody wants to track where I'm going, they just use my cell phone, and they can say I'm here in Timisoara, and in a few hours I will be in the room next because they are very accurate. And all this data need to be analyzed, and one of solution we are partnering is Splunk. How many of you knows Splunk? Get one winner in the back. So Splunk is a company and also a software who manage the data. So basically, you have three types of production of data: the cloud, private or not, and on premises. So these data are generating, so machine are generating logs. If you are working in hospital, you have the RFID, you send you have your badge, we send an order to open the doors when you are carrying the person. And these data are ingested by Splunk, they are indexed, and after the indexation, you can ask many questions as you wish. For example, some of you are thinking how many apples they will be produced in France between May and June. This is a silly question. Or how many donuts produced in San Francisco during summertime? And this is the question you never think about. And Splunk can help you because all the data have a tag, index, and you can build your own questionnaires. Maybe today you will ask what's about the number of people in this room, so it's an easy question. But in the future, how is the proportional of salesperson or technical person or other is in the room? These are questions you can ask. This is how Splunk is working. So we did a lot of intensive testing with Splunk, and with Splunk we have some dashboard like this. So we work with Splunk, as I said, we have an analysis, and with Splunk we have, if you go on that link, you can grab the netapp for e-series plugin, or if you have a FAS, you get also the same plugin for the FAS, or the storage grid, you get the same product, product for the web scale. So for the e-series, what you can have is something to monitor the storage array. Basically, you have in your data center, you have plenty of e-series, and the IT want to know what is the capacity used, what is the performances per system, and the easiest way to troubleshoot the performances is getting something like that. So you get, for example, the percentage of read, like in this corner, and you can tell the storage is oversaturated or not saturated, and you can load the system. So with Splunk, as I said, we did a lot of testing, and we test the classical Splunk architecture consisting with servers, commodity servers with internal drive or SSDs. So for the hot and warm buckets, we use SSDs. So the hot buckets means the data is ingested and easily used for a couple of days. And then the cold bucket is the archive type of data. We use 32 SSD one side, 24 on E-series. We get almost the same capacity. And for the cold bucket, we use SAS disk, and the type of RAID is RAID 10 to get the performances. And with the E-series, we use a dynamic disk pool. Dynamic disk pool is a type of protection built in inside the RAID. If you want to know more data on how works dynamic disk pool, just visit us on the Logicom stand, and I would be glad to explain how works the dynamic disk pool. In terms of replica, we need 3 copies on servers and only 2 copies on the E-series. And guess what? We did some performances, and there is on the netapp web pages technical report and explaining where come all the data. And basically, when we compare, even if we have a failure, drive failure, controller failure, all case of problems, guess what? We have a lot of performances compared to internal disk. As I said, internal disk JBOD seems to be inexpensive, cheap compared to E-series, but for the production, you will find you will invest more money to buy E-series, but your production will be sometime more important, as you see on the performances chart, and we have more than 69% of performances just by using E-series instead of internal disk. And we reduce the number of replication factors by, we get only 2 instead of 3. And if we get problems, we have in average 64% of performances. So basically, as I said, you have a drive failure, you have a controller failure, you have all failure you can imagine on the system. We are still faster than internal disk. So, who knows Ticketmaster? This is my favorite example. Who saw the movie Star Wars in last December? Everybody? Okay, so did you buy online or directly to the theaters, the ticket? Okay, so in UK you can buy a ticket online, and Ticketmaster is a company who are very famous to provide tickets for whatever are the events you can buy online. And Ticketmaster has a Splunk application who are monitoring what the people are saying on the internet, and they anticipate the number of servers and connection on the data center to sustain more customers to buy tickets. His competitor didn't anticipate, and guess what? The competitor has a connection problem. When you click the button, I want the 2 tickets to see the movies, and are arriving, I want to pay, and they have connection lost, you are lost. Ticketmaster over provision his data center in terms of connectivity, just because they track with Splunk, with the indexer, what the people said about the movies, and they said that lot of people is going to see the Star Wars movies, so they just make the right choice, they invest in Splunk, and they make a lot of money because everybody is going in Ticketmaster just to buy the ticket. This is an example of Splunk usage. Another point is the NoSQL, and we have MongoDB, Couchbase, Cassandra, HBase, whatever you name it, and this is the new way of playing with databases. So we have Couchbase as a partner, and Couchbase is a company who did database to use non-structured data, and non-structured data is difficult to manage. Couchbase did it, and basically where they use the Couchbase and NoSQL instances is for producing photos, videos, whatever, e-commerce. For example, you are, and this is the American example, you are in close to Christmas, and you want to buy a gift to your wife or to your husband, and you said, okay, I will make a book with photos, and I will go to the online, I will create my brochure, my books, and I will send to get the 1 week after. And if everybody is doing that with the pictures, with the standard databases, it will take ages. Using Couchbase will take less time. So we just reduce the time to analyze non-structured data. Real-time analytics, we use Hadoop as a framework. We use also for to analyze fraud detection. So we need to see, and we need to get the rules and what is the fraud detection and how to overcome the fraud and what to do after. So on the architecture, how works the architecture is quite easy. We have on the cloud the user request, and we get your server with the applications talking to the Couchbase cluster, which is a collection of servers and storages which index your data and put the data for your request. So basically, the issue with Couchbase is IOPS intensive, and you need to have the fastest servers and fastest access to your data. And the way to use it, and what we have tested is E-series, EF, because it's memory demanding, and we use SSDs to get the fastest answer. And this slide shows what's happening with failure, because failure has a huge impact on the performances. And basically, when you have, and we test the same as Splunk, internal drive and E-series, when the drive is failing, you get 30 seconds of no access to your data. 30 seconds, it's a long, long time. With the E-series, only 2 seconds. Just the controller found they have a drive failure. Time to realize the drive is failed, the time is 2 seconds. And the performance is dropped during the disk failure. Guess what? When you get internal servers, because you have the need to add the CPUs for the recovery, you lose almost all your performances. 92% of the performances is vanished because you get a drive failure. With the E-series, you get a drop of performances, and what we measure it's about 20%. Now rebuild time, and rebuild time is proportional to the drive capacity. With the internal drive takes 10 hours, and with the EF only 15 minutes, using the dynamic disk pool type of protection. And on the left side, this is the performances with the scaling. So adding more thread shows you we have more performances. And the latencies also, with more servers, reduce the latency. Okay. The last part is Hadoop, and Hadoop is widely used in the industry, and also in netapp. Netapp use Hadoop, and where they use Hadoop is for the auto support. And basically they use and this is the support director who told me this. Before, they use classical hardware, classical file system, and to make a search on all the database they have takes 3 months. They swap this file system to Hadoop, and the same query takes a couple of hours. So instead of waiting 3 months to scan all the database for a particular search, it takes a couple of hours. I don't remember the number, but it's between 5 to 10 hours. So in Hadoop, what is happening is the challenging you have is failure. What happens when I have a node failure, a drive failure, and on the classical one, we need to replicate your files, and replicating your file needs to duplicate 2-3 times your files. So when you get your failure, you can have disruption, or you get also performances issues. And what is important is what's happened to your production. So the view of the netapp view of Hadoop, so we call NSH is a netapp solution for Hadoop. So basically we get different layout with Spark on it. This is the engine. We get HDFS as the base, and after we get a yarn with for your map reduce. So we use the E-series building block and we create data nodes connecting to the internet link, and we have direct attachment with SAS. And we have the building block for your Hadoop. Also, we have the fast connector for Hadoop. I won't discuss this in this presentation, but for the fast part, we get the connector for Hadoop. So what we do here is we add our blocks, and instead of getting copies, we just reduce the copies to 1 or 2, 1 dot something or to 2, depending the protection you want to put. And also we are independent from the storage and the compute, so you can change your node as you wish, putting more up-to-date nodes. You can upgrade your storage without any problem. You are not tied to your. If you have inside a drive, internal drive in the system, if you want to change the whole system, you need to change the whole drive, and you need to duplicate your drive somewhere else. Also, we are certified with Cloudera, pr2, Hortonworks, depending Hadoop distribution you want. And also, when we do the calculation of the TCO, we are quite good. So basically, what are the components on the storage? We use RAID 5, RAID 6, depending the type of disk. But you get the pro and the cons. Also, in the building block, as I said, it's 4 data nodes plus 1 storage, and you can scale up as you wish. So you get something like this. You get your MapReduce Spark running on the flash disk, and the data node running HDFS on the 5000, just to get the capacity. Okay, performances is quite important, and performances is what we call, we use TerraGen and TerraSort to use the performances. And when we make a lot of performances, what we saw is using the E-series, the NSH solution, we just reduce the size when we run the TerraSort. So we are quite half. We cut by half the performances compared to we are 2 times faster than the traditional Hadoop. And also we can scale up with more nodes, and we did a lot of testing, and we have 4 nodes. We get this number of performances. 4 nodes we produce more terabytes. So the dynamic disk pool, when we use the production, this is the performances we get with 60 drive up to 180 drive per node, and we saw the scaling in terms of performances. So this is megabyte per second. We are close to 2 gigabytes per second in terms of performances using TerraSort. So the block, if you want to do the calculation, blocks on the 5600, this is the number, 2.4 gigabytes per second. This is what we have measured. Read 4.7, and if you want to increase the performances, you just add the blocks to achieve the desired performances. Adding the capacity won't affect the performances. It will just stay as is. And this is one of the concluding slide. When you compare for a given performances, classical, this is the Splunk example. when you want to use a classical internal drive, to do the same job, you need 100 indexer with internal disk to make the indexation, and after using the E-series and EF, you just reduce from 100 indexer to 20 indexer to do the same job. The last point, this is my concluding slide. When you are thinking about big data, third platform, think about E-series. Why? Because this is the versatile building block. You can do whatever you want. You can start small. You can group by the capacity. You can group by the performances. So we have the two-directional growth by performances and per capacity. And also we have the same architecture, the same controllers running either on SSDs, either on spinning disks, could be SAS or netapp SAS, and you don't need to worry about how I will manage my storage. The management will be the same for all the product line. And also, George Kuyan, our CEO, states that if customers want to increase their cybersecurity defenses with real-time analysis, they need to think E-series. Why? Because E-series is unique to store cold, warm, and hot buckets within the same architecture. It's not from me, but from our netapp CEO, George Kuyan. Do you have any questions? Yes? No? 3 minutes. Sorry. Questions? We have 3 minutes left. Quiet audience. No questions? I get a gift for you. One question, one gift. No?
Can I receive the gift? It's a question.
Go ahead, shoot.
No, it was just a question. Can I receive the gift?
That's a good question. So, I have a document for you to fill up what do you think about the presentation is for our marketing. So if you be kind to fill up the form, we forget to put on the seats. That's why. So you can come in and then grab the paper. Thank you. Yes, sorry.
I have a question.
Yes.
No one else asked.
Yeah. No. Could be fiber channel, could be iSCSI, could be SAS, could be InfiniBand if you want. Yeah. Yeah. No. Flash. So the way the servers is handling the rebuild is by copy. If you are doing a red layout, you need to copy the data, and the server allocates CPU for the rebuild and the CPU for the job. On the EF, and if you can go on Logicon booth, you can. I will explain you the magic behind. It's not the magic; it's the technical behind the dynamic display. Yeah, but we do smarter way. I can explain you. Basically, we use a decluster rate algorithm, and we are not rebuilding the entire drive, but what is missing. Okay? Thank you. No more questions? Thank you for your attention, and if you have more questions, just come to Logicon booth in the showroom, and we can discuss on everything. Thank you.